Hi everybody, in today's lesson we are going to be looking at multiplying and dividing rational expressions. So these are basically binomials, trinomials, or just monomials that have a variable in them, and they can be to a varying degree. So our objective for today is to be able to simplify these expressions, and we want to do that in the same way that we would do regular fractions. So basically, when we multiply and divide rational expressions, we're going to follow the same rules as when we multiply and divide rational numbers. So multiplying, we just multiply straight across the numerator and denominator, and then simplify by crossing off any factors that are common. Dividing, we are going to multiply by the reciprocal, and then do the same thing by eliminating any common factors. So our steps to follow are going to be to always simplify the numerators and denominators by factoring first. Then we're going to cancel out the factors that appear in both the numerator and the denominator. But one thing we have to remember is that we're always going to state the restrictions before we simplify. So keep in mind that a restriction for a fraction, the only restriction is that we cannot have a denominator equal to 0. Okay, last section we were looking at radicals. You couldn't have a negative radicand. The restrictions here are always going to be that they cannot equal 0. So our first example is multiplying. So we've got a trinomial over a binomial multiplied by a trinomial over a binomial. So our first step is to have to factor. So we're going to factor this, and it's just a simple trinomial. So we need to figure out what two numbers multiply to -4 and add to -1. And our factors should be a minus 4 and a plus 3 in the numerator. In the denominator, we have a difference of squares. So we've got a perfect square term here, subtract another perfect square. Basically, we just take the square root of the first term to get a, square root of the second term to get 3, and then our first binomial will be separated by a subtraction sign. Our second one will be separated by an addition sign. So this right here is this first rational expression factored. Okay, now we need to do this other side. And when we factor that, we end up with x minus 3 multiplied by, a minus 3 multiplied by a minus 1 over a multiplied by a minus 4. So we've just removed an a, and then we're left with a minus 4, and we factored this expression like we would any other expression. Okay, at this point, this is where we need to figure out what our restrictions are. So we've got a lot of different factors in the denominator, and we have to consider all of them. So for this particular one, it cannot equal 0. We need to set a minus 3 equal to 0, and we would determine that a could not equal positive 3. The opposite would be true here, and a could not equal negative 3. Moving on to this factor, it's just a by itself, so that means that a also cannot equal 0. And over here, a minus 4 cannot equal 0, so that means that a cannot equal 4. So all of our restrictions are a cannot equal 0, plus or minus 3, or 4. Now what we're going to do is move on to simplifying. So I've rewrote this expression out here, and then you can see that this a minus 4 will reduce with this a minus 4 to give us a 1. A plus 3 and a plus 3, these will cross out. A minus 3 and a minus 3 will cross out. All that we're left with is a minus 1 in the numerator and a in the denominator, and that's what our expression will reduce to. Okay, so this is in simplest form. We cannot cross out this a with this a because it is not common between all of these factors. Okay, with all the terms, we cannot factor it out. So moving on to our next question, we have a division question. So once again, we have to factor first. So factoring the first expression, we end up with x minus 2 and x plus 2 because this is a difference of squares. Our denominator factors to x multiplied by x minus 4. And then this over here will simplify to x plus 3 multiplied by x minus 2 in the numerator, and x plus 5 multiplied by x minus 4 in the denominator. And that's again because in the numerator we're looking for two numbers that multiply to -6 and add to 1. Denominator, we're looking for two numbers that multiply to -20 and add to 1. Okay? Now at this point, we need to look at our restrictions. So here we have x cannot equal 0, x minus 4 cannot equal 0, so when we rearrange we find out that x cannot equal positive 4. This will give us x cannot equal negative 5 and x cannot equal positive 4. So at this point we've established some of our restrictions, but we're not quite done, because in the next step what we're going to do is we're going to multiply this first fraction by the reciprocal of this. So notice we brought the x plus 5 and x minus 4 into the numerator and switched x plus 3 and x minus 2 in the denominator. Once we complete that switch, we now have two new factors in the denominator, so we have to consider those non-permissible values as well. Here we have x plus 3, that cannot equal 0, so x cannot equal negative 3. Over here, x cannot equal positive 2. So up here I've listed all the different non-permissible values for x. Once we've completed that step, what we're going to do is we're going to start simplifying by crossing out our common factors. So we have an x minus 2 over here, x minus 2, that will simplify, x minus 4 and x minus 4, and that leaves us with, so you've seen we've crossed them out here, and that leaves us with x plus 2 in the numerator multiplied by x plus 5 in the numerator, and in the denominator we have x multiplied by x plus 3. That's the fully simplified form there, okay? We don't expand, that's the exact way that we leave it, okay? Last example, this time it's a little bit trickier because we have this expression divided by this, and then we're going to multiply it by this. So we have to remember our order of operations, and first we're just going to focus on the division part of this expression. So in order to divide, of course, we have to factor first, and in this numerator you can see we have to factor through decomposition. So we need to multiply 2 by negative 15 to get negative 30, and then we want two numbers that will also add up to negative 7. Two numbers that multiply to negative 30 and add to negative 7 are negative 10 and 3. We rewrite negative 10m and positive 3m in the place of 7m. So we've just decomposed that. Now what we're going to do is we're going to group them and remove the common terms. So from this group here, I removed a 2m, leaving us with m minus 5. And from here, I've removed a 3, leaving us with m minus 5 as well. So our two factors are 2m plus 3 and m minus 5. So I'm going to write that in our numerator. Oops, sorry. Write that in our numerator. So we have 2m plus 3 and then m minus 5 in our numerator. In the denominator, I'm going to factor out a 2m, leaving us with m minus 5. Now I'm going to factor this 4m squared minus 9. This is also a difference of squares. Okay? What I'm going to do is I'm going to rewrite this as a reciprocal. So you notice that I brought the 6 into the numerator, and I factored this to create the denominator. So I have 2m minus 3, 2m plus 3. I got that by taking the square root of 4m squared, giving me 2m, and the square root of 9 to give me 3. At this point, what I'm going to do is I'm going to state some restrictions. So here, m cannot equal 0, m cannot equal 5 here, and then for both of these factors, I need to set them equal to 0 and isolate m. When I do that, I should find out that m cannot equal plus or minus 3 over 2. From here, what I'm going to do is simplify. So when I simplify, I'm going to simplify across the fractions because they're multiplying. So I can take this 2m plus 3 and this 2m plus 3 and cross those out, m minus 5 and m minus 5, leaving me with this 2m here, 2m multiplied, or minus 3 and 6 in the numerator, which would give us 6 over 2m multiplied by 2m minus 3. Now I'm going to bring in this second part of the equation here. Okay, so I'm multiplying it by 3 minus 2m. Don't forget that that's over an invisible 1. So when I multiply these straight across, what I can do is I can simplify. Now you'll notice from last section that this is a positive 3, this is a negative 3. This is negative 2m. This is positive 2m. These are those opposite factors that are going to reduce and give us negative 1 as an answer. So now I have negative 1 multiplied by 6 over 2m, which becomes negative 6 over 2m. Simplify and I get negative 3 over m. Okay, so you're using a lot of factoring, a lot of simplifying in this chapter, as well as a lot of algebra to determine these restrictions on the variables. Okay, so hopefully that was pretty clear, and we'll talk more in class tomorrow if you have any questions.